Welcome to your last virtual lab for this year, Lab 17, Acid-Base Titration. In this lab, you are going to titrate an acid of known concentration with a base of unknown concentration with the goal of determining the concentration of the base. So here's the premise behind the lab. You are a chemistry student at the Whoopsacola Institute of Technology. As part of your general chemistry course, you have agreed to set up a lab utilizing sodium hydroxide solution. Your professor tells you that the solution has already been made, but he doesn't remember the concentration of the base, but it is vital to the success of the lab. He says not to worry about it. He put a label on the flask containing the sodium hydroxide solution with the formula, concentration, and preparation date on it. Satisfied, you leave him to prepare the lab. You first take an extended coffee break and return to the lab, only to find that some prankster has crossed out the concentration on the label. The professor is nowhere to be found, and the lab is to start in half an hour. After regaining consciousness, you review your options. You may 1. Drop out of college while you can, or 2. Perform a titration of the sodium hydroxide using the bottle of standardized HCl conveniently nearby. Being a conscientious chemistry student, you opt for Plan 2. Now, acids neutralize bases, wherein the hydrogen ion from the acid will neutralize the hydroxide ion from the base to form water. And as long as there's an equal number of hydrogen ions and hydroxide ions, or more accurately, the same number of moles of hydrogen ions as you have moles of hydroxide ions, you will reach a neutral solution, which is a pH of 7. Now, we could use a pH probe to determine when we reach this equivalence point, the point at which neutralization has been achieved by reading a pH of 7, but we're going to use an acid-base indicator called phenolphthalein. Phenolphthalein is colorless until a pH of approximately 8, at which point it begins to turn light pink. We call this the concentration at which the indicator begins to turn color. We call this the end point. Now, the end point is not the same as the equivalence point. The equivalence point is a pH of 7 for phenolphthalein. The end point is a pH of 8. And you may think, but that's a whole pH value. Yeah, but because of the way logarithms work, it actually turns out to be less than 1 drop of difference between a pH of 7 and a pH of 8. And therefore, the end point will serve our function perfectly. Now, what we're going to do is, using a burette, we are going to titrate the acid and base. We're going to do 4 trials. For the first trial, we'll record the starting volume of the acid and the final volume of the acid after the endpoint has been reached. The starting volume of the base and the final volume of the base. And you will simply subtract to get the volume of acid used during that trial and the volume of base used during that trial. Instead of refilling the burettes between each trial, what you will simply do is whatever your final volume is from one trial, we will start with that volume in the next trial. So whatever your final volume of trial 1 is, just write it in as your starting volume for trial 2. Whatever your final volume for trial 2 is, write that in as your starting volume for trial 3. This way we don't have to refill the burettes every time. Now, there's space here for 5 trials. We're only going to do 4, and then using the volume of acid and volume of base and the concentration of acid we will be using, which is 0.100 molar HCl solution, we will use the equation MAVA equals MVB, molarity of acid times volume of acid equals molarity of base times volume of base, to actually calculate the molarity of the base. For each of the 4 trials, and then you will average those trials and then calculate the percent error. When you're all finished, there are some questions to answer on the next page. All right? So get your data table ready, and we are going to start with our first trial for our titration. These are our burettes. In the left burette, we have our 0.10 molar hydrochloric acid, and in our right burette, we have sodium hydroxide of an unknown concentration. I have set the starting volume for both the acid and the base at 0.00 milliliters. So you can write that down for your starting volume, VI, initial volume, of both the acid and the base for trial 1. Next, I'm going to add 10 milliliters of the acid to this Erlenmeyer flask. Now that I have 10 milliliters of acid in the flask, I will add the indicator phenolphthalein, 3 drops. Oh, I put in 4. That's okay. You'll notice that it remains colorless. And what I will do is I will titrate this with the base until 1 drop makes the difference between it being clear and staying pink. And now we are ready to titrate with our base. Here we go. You'll notice the pink color develops and then goes away upon swirling. This is because there's still a higher concentration of hydrogen ions than hydroxide ions. So the pH is still less than 8. But as I add more pink, it takes longer for it to disappear. So consequently, I will add less and less as we get closer to the end point. Uh-oh, we are very close now to the point where 1 drop will make the difference between clear and pink. And there we are. That is the end point for our first trial. So now that we have our end point, let's get our final volume of acid and final volume of base, which remember will become your initial volume of acid and base for trial 2. Make sure to read this device very carefully. It is marked to the 10th of a milliliter, and you read it upside down of the way you would normally read a graduated cylinder. Volume of the acid. Final volume of the base. Okay, now I'm going to rinse out our solution and do the second trial. It doesn't matter if there's water left in the flask because water is neutral and therefore will not affect the outcome of our experiment. So I'm going to drain from 10 down to 20. Yeah. Now that we have exactly 20.00 milliliters of acid, I will go and add my 3 drops of phenolphthalein. 1, 2, 3. And now let's do our second trial. Remember, the end volume for trial 1 is your start volume for trial 2. All right, let's begin adding the base. Okay, now I added far more than just one drop to get that. So I'm going to clear it up by adding a little bit more acid. This is what's called back titrating. And now let's go back in and be more careful about adding the base. One drop, another drop, another drop, whoops, and there we have it. Final volume of acid. Final volume of base. Now it's time for trial 3, so once more we will empty out our flask and put in another 10 milliliters of acid. Remember the final volume from the last trial? You just copy those numbers. That's the initial volume for the second trial. Okay. Now let's add our 3 drops of phenolphthalein. And titrate it. Here we go for trial 3. Okay, let's just add the 1 drop. There we go. We have our end point. Okay, let's get our volumes for trial 3. Final volume of the acid. Final volume of the base. Okay, one more trial and we are done. So let's give it a final rinse. And drain out 10 more milliliters of the acid. Let's add our 3 drops of phenolphthalein. And get set up for our 4th and final titration. Okay, one last time. The final titration. Let's get our volumes. Final volume of the acid. Final volume of the base. Well, ladies and gentlemen, thank you so much for joining me for this video series of virtual labs. You can go ahead and work on answering those questions now, calculating your molarities and doing the analysis and all the rest of that. I hope you've enjoyed this. I hope you've gotten a lot out of it. And thank you very much for being with us through this 17 video series. You guys take care of yourselves, look after your families, and be well.